Kepler Telescope was built for one purpose: to look at certain patches in the Milky Way, in search of exoplanets. This exoplanet hunters observed over 1,000 of stars and discovered many exoplanets during its lifetime. Delta II rocket was launched in 2009. As part of NASA's Discovery program, the main task was to constantly scan a fixed patch of sky within our Milky Way galaxy, to find planetary systems. At the time of its launch, it had the largest primary mirror ever sent into space. And it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop, and its 9 years in space. Kepler observed over 530,000 stars and confirmed the existence of around 2,662 new exoplanets. These exoplanets are unlike anything we have ever seen in our solar system before. Most of them aren't significantly bigger than Earth, and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have the star-facing sides with temperatures that can melt iron and half entire hemispheres covered with oceans of liquid molten rock. Some exoplanets are the size of Jupiter, orbit not one but two stars. If you were standing on the surface of one of these planets, you could be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as the habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life. The presence of water is significant, and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K218b. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth. K218b is about 8 times the mass of Earth, and 3 times as big. It orbits a main sequence red dwarf star called K218. A red dwarf star is the smallest, coolest star, and by far the most common type of star in the Milky Way. According to capitalist data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K218b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the start dims slightly. And that's how we can tell that there's a planet there. The level of dimming, and how long it lasts, gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109 of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity using the same method. Way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now, a new study indicates the exoplanet 500 light-years away may also have seasons. And the climate similar to our own. New research out of Georgia Tech. The university has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Capital 1649c. In mid-2020s, while combing through old Kepler data and matching it against new data from the Transients Exoplanets Survey satellite, or TESS, astronomers confirm the existence of another exoplanets, with very favorable conditions for life. Kepler 1649, co-located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from a toaster, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2,662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone, and out of the 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface with a planetary core of rock, and if the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all of this, despite being cooler, red dwarf stars tend to be more active than sunlight stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 1160 degrees Fahrenheit or -73 to 47 degrees Celsius. That means the surface could on average be colder than Antarctica, or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds, and comprehensively answer all these questions yet, but don't despair. Based on the statistical analysis of all the Kepler observations, astronomy is now estimated that 1 in 5 stars like the Sun have planets about the size of Earth and surface temperature conducive to life. Given that about 20% of stars are sunlight in our galaxy, that amounts to several billions of potential habitable Earth-like planets, just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets. In fact, the bulk of its discoveries with strange worlds, not suitable for life but fascinating nonetheless, like the gas giant planets composed mostly of gases such as hydrogen and helium, with a relatively small rocky core, also known as hot Jupiters. These planets orbit extremely close to their parent stars under abundant in capitalist data. One such fascinating example of a gas giant is Koi 5ab. Astronomers first flagged Koi 5ab as a potential planet way back in 2009. At the time this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago. Firstly, due to the enormous amount of data that Kepler generated. And secondly, because astronomers noticed that the main employee 5A star had another companion stop, making analysis very difficult for them. Indeed, the KOI 5 system was even more complicated than researchers realized at the time. By 2014, scientists determined that the KOI 5 system actually harvested 3 stars, and it still wasn't clear if the planet KOI 5AB actually existed, or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the test satellite, scientists were able to confirm the existence of KOI 5AB planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of KOI 5AB is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler, including super-Earths, they're more massive than Earth, yet lighter than ice giants like Neptune and Uranus, and can be made of gas, rock, or a combination of both. Lava planets, as super-dense, larger than Earth worlds in close, hot orbits around their parent stars. Some of them, known as two-Tholian planets, are likely the remnant cores of evaporated hot Jupiters. And finally, Trojan planets, planets of various size found in strange locations, and sometimes even as companions to larger planets that have been certainly identified yet. Kepler was finally retired on the 30th of October 2018, as it ran out of fuel. The telescope was deactivated with a good night command sent from Mission Control the next month. Coincidentally, Kepler's retirement fell on the 338th anniversary of Johann Capitel's death. After him it's named, although not operational anymore. These incredible discoveries predict a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. One such telescope is already slated to go up into space. In 2021, the James Webb Telescope will take a much closer look at some of these Kepler objects of interest, and hopefully will bring us closer to answering the question: are we alone in the universe? What do you think? Will astronomers find many more strange worlds buried inside capitalist data? Let us know in the comments section.